This is a cycloidal actuator, and this is the leg it's installed into. And today, you're going to learn how to build one. Diving in, this gear reduction is characterized by its ability to be primarily FDM printed, with low backlash and high impact resiliency, hence why it was selected for the base version of OpenMutt. While this guide may be useful in assembling other cycloidal reducers or actuators, it is specifically intended to be a guide in assembling Block 1 versions of the OpenMutt cycloidal actuator for the open source research testbed developed at Embry Riddle Aeronautical University and featured in SPIE's Disruptive Technologies and Information Sciences 8th edition. As the designer of this actuator, I'll walk you through the steps required to assemble one. Now that we're ready to build, we're going to use this link up here and we're going to get all the materials we need together. Then we're also going to need an M2, M2.5 hex key, a number 2 Phillips screwdriver, a soldering iron, a hammer, and a flat punch. To punch in those washers into the main cycloidal body, we're going to use our soldering iron to put in those M3 heat set inserts. And we're going to be able to just use the hammer for the blue top section of the body. Now, for the torque transfers, we're going to need a little extra attention to these. We're going to start with the top one. We're going to need to put one of the big bearings around it. If you put it on, by putting it on beforehand, it is not going to mess with those washers once we press them in, so they won't come loose and fall out. Then we're going to put one of the middle-sized bearings into the bottom section of the torque transfer. So that way, when we heat press those big 1024 heat sets in like this, it's going to be all nice and snug. Talk about our next step of the prep work, which is taking the motor side of the crank assembly, and we're going to be taking the two M3 nylocks and we're going to be pressing them in so the nylock is facing towards you in this view. We're going to be using our M3x30 socket head screw and the back of that to help push it in. So now we're going to take our motor with the male side banana connectors soldered on, and we're going to take our crankshaft and we're going to pop it on to the output shaft of the motor. You're going to feel it snap into place when it's centered, and then you just rotate it till the 4 screw holes line. We're going to take our screws, we're going to put it into those holes. We're going to use the shorter ones, but when we're tightening those, we're going to make sure we do it in a star pattern to prevent warping. Next, place the torque output on top of the motor, place the bearing on top of it, and then place the housing on top of both. Press hard until you have a gap of about this big. Then put a peg into each of the holes. It may take a little bit of hammering to get them down and in, but once you have each of the pegs in, you can place the bushings on top of each of the pegs until you have something that looks about like that. Next, it is time to put the housing back on top of the motor, like so. Now, time for some white lithium grease to lubricate the gearbox while not breaking down the PLA. Then, place the small bearings inside of each of the cycloidal discs, placing the yellow one on the bottom with the lip facing up. Align the brass bushings to the holes, and then place some more lithium grease on top, and then place the red on top of the yellow, this time having the red's lip face down. Again, this is to have the lips facing opposite. Use the Allen key to align up the 2 discs through the 2 alignment holes, and then time for some more white lithium grease on top. Now, take the 5 remaining bushings, place them into each of the holes, then place the blue ring on top, making sure those holes are aligned with the brass bushings underneath. Place the torque output into the center. Next, install the 5 1024 screws into the holes. This is a temporary install. Over-tightening the screws at this stage will result in permanent damage to the gearbox. If the threads do not catch into the metal inserts, simply place 2 screws in and an Allen key in the 3rd hole and rotate until the Allen key drops down, indicating it is aligned. Next, take the remaining section of the crankshaft, 2 of the M3x30 screws, and the bearing, and assemble it into the gearbox. You will know if it is assembled correctly if the crankshaft is sitting below the torque output. Next, install the front cover using the remaining M3 flathead screws, tightening in a star-shaped pattern. Now it is time for the motor cage. Install the ring with the V side facing up. Then the top cover, placing the wires through the hole with the extra cutout so that they can lay flat. Use the remaining M4 screws in the middle and the M3 screws on the outside. Over-tightening the M3 screws on the outside can result in a side load on the bearing and extra resistance. Now that you have your gearbox assembled, it is time to verify it works. Grab the 5 output screws and turn it by hand. There should be no scraping noise. And it should turn equally the same resistance both ways. If you have any anomalies, separate the 3 motor wires to make sure no back EMF is occurring. And there you go, a functional cycloidal gearbox to install into your OpenMutt or any other project. Remember to always build big and dream bigger.